Scientists are beginning to pick apart the data surrounding the supermassive black hole at the center of Messier 87, an object historically revealed this week as the first black hole ever directly imaged. It sits 55 million light-years from Earth, and is estimated to have a staggering mass of about 6.5 billion times that of the Sun. Observations from NASA's Chandra and New Star satellites now reveal it's also ejecting high-energy particles at nearly the speed of light, spewing material more than 1,000 light-years out. The NASA observations were used to measure the X-ray brightness of M87's jet, which was then compared with the models and observations from the Event Horizon telescope. There are many mysteries about the nature of black holes, including why some eject material in these jets, despite being known as inescapable objects. It's hoped that the latest observation breakthrough will help to answer some of these long-standing questions. High-energy particles that make up M87's jet are shooting out from a region near the event horizon, and has been observed to be mysteriously dimming and brightening. X-rays help us connect what's happening to the particles near the event horizon with what we can measure with our telescopes, said Joey Nielsen, an astronomer at Villanova University in Pennsylvania, who led the Chandra and New Star analysis on behalf of the ET's multi-wavelength working group. Scheduling all of these coordinated observations was a really hard problem for both the ET and the Chandra and New Star mission planners, Nielsen said. They did really incredible work to get us the data that we have, and we're exceedingly grateful. The April 10th event focused on the results from the first full run of the Event Horizon Telescopes network, which was conducted in 2017. Using a virtual telescope built from 8 radio observatories positioned at different points on the globe, the international team has spent the last few years probing Sagittarius A, the supermassive black hole at the heart of the Milky Way, and another target called M87 in the Virgo cluster of galaxies. While black holes are invisible by nature, the ultra-hot material swirling in their midst forms a ring of light around the perimeter that reveals the mouth of the object itself based on its silhouette. This boundary is known as the event horizon. We have seen what we thought was unseeable, said ET Director Shepard Dolman as he introduced the glowing orange ring that is the object at the center of Messier 87, M87, and our first direct look at a black hole. The breakthrough adds major support for Einstein's theory of general relativity, and could help to answer long-standing questions on the nature of black holes. Developing the technology to get the image was a Herculean task in itself, the researchers said. No single telescope is powerful enough to image a black hole in such detail on its own. But, through international collaboration and an array of instruments, the team built a virtual telescope essentially as large as Earth itself, allowing them to peer into Messier 87, which lies 55 million light-years away, to see the black hole at its center. The data required more than half a ton of hard drives, according to Dan Maroney, Associate Professor of Astronomy at the University of Arizona. The 8 telescopes collected 5 petabytes of data, or the equivalent of 5,000 years of MP3s, or a lifetime of selfies for 40,000 people. We now have visual evidence for a black hole, Dolman said. We now know that a black hole exists at the center of M87. Material moving around the black hole is moving at light speeds. We now have an entirely new way of discovering black holes that we have never had before, and like all new discoveries, this is just the beginning.